thing is pull your shapes individually apart and make sure you write down their area equations. So that right there, I'm going to do a little baby version of it. That's going to be area equals base times height over 2. All right? Yes. Work in pi form until the very end. It's easier. And then this one right here is, of course, a rectangle. So I'm just going to do a baby version. That's area equals length times width. And then this, of course, is a parallelogram. And that's area, that's a bad parallelogram, equals base times height. So, couple rules. Always, when you do little baby versions, so you keep track of it. I recommend you even color code and write all your equations out. Let's double check this, double check your work. Most of you did fine. Okay, so this one, area equals my base here. Wow, it's not there. So watch what I do. I ask what I do have. I don't have my base, but I do know that's a rectangle, so that's the same, right? And then you know this is a parallelogram, so that's the same. Bam, I just found my base. My base is, I walk it over, 9 times 7 over 2. That's 63 over 2, 31.5 units squared. Length times width, 3 times 9. Yes, I used my 9's fingers. For 9 times 7 and 8 times 7, 9 times 6, I have to do that. This is 9 times 3, which is 27 units squared. To that guy. This one's just base times height. Again, my base is 9. The trick to this is you had to find my height, which is if you trace it and you bring it down, that's right from here to here. Do you see the difference? So you have to figure out from here to here is 7. From here to here is 3. So that is 10, which makes your height here 6. 56. You add it up, 112.5 units squared, and you are done. 54. Yes, 54. That's why I have to use my 9's fingers. That's what happens when I don't use my 9's fingers. 54. Okay, ready? Now, you add it up. You add it up. Okay, ready? Now, sounds like you got it right. Okay. I want you right now exactly where did you drop the ball? Think about it. 10 seconds. And I want you to tell somebody, where did you drop the ball? 10. Ready? Tell someone, where did you drop the ball? What'd you forget? Go. What happened, Isaiah? Yes, sir. Okay, did you get that height? Did you get the 6? Okay, that was, did you physically trace it? Yeah. Got it. All right. Now, today, we're going to get areas, and we're going to start using it. We're going to do 3 examples together. Geometric probability involves probability associated with concepts of area and volume. That's why it's called geometric. Obviously, there's different kinds of probability. So if I want to find the probability that a point is in the space of B compared to the whole of the A, I would simply find the area of B, divide by the area of A, and I change it ultimately to a percent. So all your answers together, and you have a whopping 2 pages today. All righty. It says find the probability that a random point lands in the shaded region compared to the entire circle. So right now, it's always, we know that percent equals part over whole. So it's very critical that you define what your whole is. So our whole, it says right there, is the entire circle. So I go like this, and I write whole, and that's going to be my entire circle. So right off the bat, how do you find area of a circle? Apple, pi. Really, really good. Thank you for saying A equals. You guys are getting better trained. Thank you for not just saying pi r squared. Okay, and my part, of course, draw a little arrow. My part is the shaded region. The shaded region, however, is a composite shape. It's called a negative composite shape, which means we have to subtract something from something else. So the shaded is the area of that circle, and we're going to minus this shape. Okay, ready? I'd like you to write the area equation for that shape right underneath it. Write the area equation. Okay, Hayden, which area equation did you use for the green? Side squared? Okay, there's another equation we could use there. What is it? Yeah, guys, all squares are technically rhombuses as well, or rhombi. So be very careful. Okay, now let's do our footwork. Step number 1. You have 10 seconds, and I'm going to land on someone. I want you to find the radius. 10 seconds of silence. 10. Brianna, what's our radius, ma'am? 10. Yes, and that's because you should have seen that your diameter, if we go like this, we can rotate it and go like that, which makes our diagonal there 20, which makes our radius 10. So we're going to go here. 10 times 10 is, okay, so 10 squared times pi. That's 100 times the pi key. Now, we can't leave that in pi form because we're going to subtract something else. You should be able to do this in your head. Pi, 3.14. That's 3.14. Move the decimal over twice. What do we get? 314. Now, minus, we come over here. We could easily find these side lengths because it's a square. We could do. Do we have the diagonals already? What's one diagonal? No. Diagonal. 20. What's the other one? 20. What's 20 times 20? 400 divided by 2. So that's 200. Oh, looky there. Do you see why you want to write down both equations? Okay, so that means our shaded region, 314 minus 200, our shaded is 114. Whoa, good call. Good call. You guys are on top of it. No, just the shaded. Shaded. Now, to get our percent, we do part, which is our shaded, because we want to find out the dot inside the shaded, so that's 114, divided by the whole, which is what number? 314. At this point, you may grab your calculators. But look how far we got without a calculator. Take it to the second decimal. this case is? Lovely. All right. I want 10 seconds of silence. I want you to hold 3 fingers, please. I want you to think about the 3 main steps, the generic steps. In your explanation, I went no numbers. I just went description of the process. I want you to come up with 3 steps in your own brain and be ready to share it with someone. 10 seconds of silence. Share your 3 steps with somebody. Step 1, I want to see fingers. Step 1, step 2, step 3. Go. All righty. Ready? One more and we're done. I want you to read underline keywords. Go. Okay. Ready? We want the probability that a point is in the shaded region again. So put a point in the shaded region, right? Question mark. Compared to the entire circle. That defines your whole. Your part is this. So always make sure right off the bat you identify your part and your whole. Let's start with the big picture. Percent equals part over whole. You okay so far? Okay. Let's draw our pictures. Whole's easy. We go like this, and I even like to write the word whole so I keep track of it. Write out your area equation. And since I'm finding the whole, I'm going to shade it. All right. Physically trace your radius. Out loud, what's your radius? 16. So we're going to go 16 squared times your pi key, and because we have to do something else with it ultimately, you may change that to a decimal. Take that to the second decimal place. Let's just do everything to the second decimal place today. 4.25. And check for units, no units, so that's units squared. And again, I'm going to rewrite it, and I'm going to write the word whole. Always label your stuff. There's going to be lots of footwork here, so get in the habit of labeling your stuff. Now, the shaded region is a composite. So the shaded region is going to be the circle minus the what? Do you see it? You have to minus this. So let's draw that. And that is going to get your shaded, which we need. Okay, so right here, I'd like you to write the area equation for that shape. Area equals. Out loud, what is it? Perimeter times apothem over 2, pi over 2. How about this? How about we physically trace our perimeter? Let's come over here, physically trace it. Do you have your perimeter right now? No. Nope. Okay. So we don't have our perimeter, so we're going to put P equals, we don't know it yet. Physically draw in your apothem. Do we have your apothem? Oops, we don't have anything here. Okay. But behold, friends, what do we have? What kind of triangle do we got going on here? Oh, yeah, we're getting there. We're getting there. You're ahead of yourself, but yes. Okay, what I'd like you guys to do, please, is draw in your radii. Draw in your radii. First thing I want you to do is find the orange sweeps. Go. Find the orange sweeps. I'll give you 10 seconds. I'm going to land on someone. Find those orange sweeps. Justin, what's the orange, buddy? You're taking a circle, right?
Yeah.
Dividing it by what, sir?
Divided by the side.
How many sides do you have? Excellent.
So 360 divided by 60 is still 6 is 60.
Excellent. Okay, so all of those guys are 60, which gives us right here a 30, 60, 90 triangle. Now, let's pull this out so you can see it. Remember that right triangle stuff? Wow, it comes back to haunt you yet again. We need the apothem. We're going to call the apothem X. And we need this half side, which I'm going to call Y. And then this is 30. Okay, you could use 30, 60, 90, but then so when I know that ahead of time, and I know I don't need exact terms, I'm going to use SOHCAHTOA. So we're going to do two different channels of SOHCAHTOA, one to solve for X, one to solve for Y. Okay, ready? Have, need, do. Have, need, do. Track with me here. From the 30, let's label from the 30. That's opposite. That's adjacent. That's our hypo. Holler at me if I lose anybody. We're almost done here. So for X, let's do this together. For X, we have the what? Out loud, guys. Hypo. And we want the adjacent. We write it down. Cosine of theta over 1 equals adjacent over hypo. Second is fine. Cosine of 30 over 1 equals now x over 16. Stop there for a second. I'm going to set both of them up, and I'm going to let you go for a minute, and you solve for both. Let's go to the y here. Y, we have the hypo. We want the opposite. What goes with O? So it looks like this. Sine theta over 1, opposite over hypo. That's sine of 30 over 1, opposite, which is our y, over hypo, which is 16. Ready? I'm going to freeze it. You solve for both. Go. Solve for both. Take your answers to second decimal place. Yes, I know you're all happy. One of them's a whole number. It is easy. 13.8. Take it to the second. Okay, guys. Y is easy. What's Y? 8. Straight up 8. To the second decimal place, what's X? Depending on how you round, either 13.85 or 13.86. Okay, now we come back to what we wanted, which was perimeter. So we walk it around, that we double that 8. Physically walk it around, so our perimeter is going to be 6 times 16. That's our perimeter. Times our apothem, which is 13.86 over 2. Go ahead and do your math there. Check your math with mine. Or check my math with yours. Are we getting the same thing? Did I click wrong? Okay, let's double check. That's going to be 96 times 13.86 divided by 2. That's better. Yes? Okay. 665.28. And remember, that's not our shaded region. Okay, that's our hexagon. So to get our shaded, we have to subtract those two. Subtract those two. And you're going to get your shaded region. Perimeter is 6 sides. Okay. Let's see. Shaded region is, so I lost my calculator. Where'd it go? Is that it? No, that's not it. That's not it. Is that your shaded? No. Where'd it go? What's the shaded region, guys? Do you have that already? 138.097? Okay, 97 units squared. Now to get our percent, we put that over the whole, which is 804.25. Divide gets a decimal, and that gives you percent. It's rather small here. 138.97 divided by 804. What is it? 25. And that's approximately 17%. What's really nice about these is they're kind of drawn to scale, which means kind of guesstimate. Estimate before you do this. You can see right off the bat that that's not 50%, right? Just guess right off the bat. And start working. Alrighty, guys, you have 40 minutes to finish 4 measly problems. All right, lights, please. 17%. 17.3%. Yes. Yes, sir.